What we are talking about this entire unit is right triangles. Okay, there's so much that we can learn about right triangles that we have an entire unit devoted to that. You guys started last time talking about the Pythagorean theorem and then the converse of the Pythagorean theorem, which we use to classify triangles, like on number 5 on your warm-up. Okay. What we are going to focus on both today and on Wednesday are what we call special right triangles. There are 2 types, and we are going to do one type today and then the other on Wednesday. So our goal for today, or our objective for today, is to look at and investigate. That's what you guys are going to do here in a minute. What you're going to investigate is the relationship among side lengths of isosceles right triangles. So let's think for just a minute about what an isosceles right triangle would be. So think back to first semester, even way back to middle school when you guys first started classifying triangles. An isosceles triangle means what? Raise your hand. Rachel.
The 2 sides are the same length.
Okay, so an isosceles triangle, we have 2 sides. At least 2 congruent sides, which means they have the same length. And a right triangle means what? It has a 90-degree angle, a right angle. Okay, so all of the triangles that we are looking at today will have a right angle and will have 2 congruent sides. Okay. What you guys are going to look at first is how the lengths of the 2 sides compare to the length of the hypotenuse. Okay? How the lengths of the sides or the legs compare to the hypotenuse. Okay? So what you guys are going to do first, as it says, find the length of the hypotenuse of each triangle shown below. Show all work and leave all lengths as simplified radicals. You should not have any decimal approximations here, okay? So what you guys did on numbers 1 and 2 on your warm-up, that's what you need to be doing. Simplify the radical. Do not take the square root using your calculator. So, with that being said, why don't we do the first one together? So, using the Pythagorean theorem, we can find the length of that hypotenuse. Okay? So, think of those legs as A and B. We're looking for the value of C. So, in your workspace, we can take 1 squared plus 1 squared equals C squared. That 1 squared is still just 1 equals C squared. I can add those together, so 2 equals C squared. And then to get C by itself, we take the square root. So the length of C is radical 2. There's actually nothing that we need to simplify on that one. Okay? So again, what you guys are going to do is the same thing for these other 2 triangles with legs of length 2 and 3. Hang on just a second. Let me go ahead and explain the rest of these directions. Pens down. Pens down. All right. So after you guys find the lengths for the hypotenuse on the other two triangles, you might start to see a pattern. Okay, that's the goal here. So what you are going to do then in number 2, like it says, record your findings in the chart below. So you have the length of the legs up here. So you have the answers, or you will, for lengths of 1, 2, and 3. If you need to continue to use the Pythagorean theorem for the rest, you can do that. If you're seeing a pattern, then that's fine too. You're going to get all the way down to a general leg length of L. So hopefully the goal is you see a pattern and then you can generalize that. You will then answer a couple of questions down here with your table. So I'm going to give you, I don't know, 7 to 10 minutes. We'll kind of see how you're doing. 7 to 10 minutes to get through number 5 with your group. Okay? Go. Yeah. All right, let's go ahead. Most of you guys were doing a pretty good job from what I saw and heard. Let me go to Colton, your group. Tell me what you guys ended up with. Well, first of all, we know that we got, because we did this part together, for a leg length of 1, we got radical 2 as the length of the hypotenuse. What did you guys get for leg length of 2 and 3?
2 radical 2 and 3 radical 2.
Okay, oops. So a leg length of 2 has a hypotenuse length of 2 radical 2. A leg length of 3 has a hypotenuse length of 3 radical 2. Nolan, what did you guys get for leg length of 4, 5, and 6 for the length of the hypotenuse?
4 radical 2, 5 radical 2, 6 radical 2.
Okay. Emily, what did you guys get for 7, 10, 20?
7 radical 2, 10 radical 2, 20 radical 2.
And Bailey, your group for 50, and then L.
We had 50 radical 2, and then
L radical 2. Okay. Number 3, discuss with your table any relationships you see between the length of the legs and the length of the hypotenuse. Record your discussion below. Brittany, what did your table talk about for number 3? The leg length is L. Okay, relationships between that leg length L and the length of the hypotenuse. Well, no, they're not the same. 1 and radical 2 isn't the same. 2 and 2 radical 2 isn't the same.
So it's like always going to be the same.
What's... Okay, elaborate on that.
Okay, the leg length is the same as the hypotenuse, and then you just add that.
Okay. All right, we're getting there. Steve, what did your group say for number 3?
I said the leg holds a numerical value outside the radical, and the radical is always radical 2.
Okay. Shannon, your group.
We said the length of the legs is the one outside radical and the hypotenuse is radical 2.
Okay. Artem, your group on number 3. Ooh, I like that one. Not that I didn't like the other groups.
Right.
That gets like right to it though. The hypotenuse, write this down, is equal, say that one more time.
Hypotenuse is equal to the leg. 2 radical the leg, I guess.
Yep. Hypotenuse is equal to the leg times radical 2. That gets directly to that relationship. And you guys saw that. Maybe you couldn't quite put it into words that succinct maybe, and that's okay. That's why we all talk about it together. But I think from what you guys told me in the chart, you saw that relationship and you saw that pattern. Okay. So let's complete number 4. In an isosceles right triangle, if the legs have length L, then the hypotenuse has length. Mark, what did you guys fill in for number 4? L radical 2. Again, just kind of restating what Artem said in number 3. Then number 5, kind of testing that conjecture. Without showing any work or using your calculator, find the length of the hypotenuse that has 2 legs with lengths of 3,000 inches. Carrie.
Well, I got 3,000 squared plus 3,000 squared equals...
Okay, without showing, I wanted you to do this without showing any work. Based on what you guys should have seen at the beginning of this. If the legs are 3,000 inches, what's the length of the hypotenuse? Exactly, 3,000 radical 2. Okay, you guys are going to carry this pattern through the next few examples. All right, if page, what we're going to do is just summarize and state again what you guys saw in that investigation. So in a 45, 45, 90 triangle, the hypotenuse is radical 2 times as long as each leg. So we have leg in the picture AC and leg BC. The length of your hypotenuse, which in this picture is AB, would be the leg length times radical 2. The leg length times radical 2. Exactly what you guys saw in that investigation. That's essentially all you have to take away from today. Now we're going to look at some examples with this, of course, but that's the big idea. In a 45, 45, 90 triangle, or isosceles right triangle, same thing. The hypotenuse is the leg times radical 2. So, with that being said, let's look at the first example. If we have a leg length of 8, first of all, let me ask you this. What is the length of the other leg, Justin? 8. Okay, we know the legs are the same. Here's what I want you to do to get us started. I want you to write out this relationship. Hypotenuse equals leg times radical 2. Even if you think this is so easy now, I promise this is going to help you because I will make this harder. Write out that relationship. If you write out that relationship, it will be easier later on. Once you have that relationship written out, we're going to fill in what we know. The hypotenuse is the x, so we can fill that in. The length of the leg is 8. Fill that in, and then bring down times radical 2. Then from here, to solve for x, we just need to multiply those. That's just an 8 radical 2. Write out that relationship. Write out that relationship. Because if you look at number 2, I go ahead and I make it harder for you. If you're trying to work ahead, you may have gotten stuck. What's different about this one compared to number 1? Shannon?
It gives you a hypotenuse, not the legs.
Okay, this one we're given the hypotenuse, we have to find the leg. Start by writing out the relationship. The hypotenuse is equal to the leg times radical 2. The hypotenuse is equal to the leg times radical 2. And let's fill in what we know. Well, this time the hypotenuse we're given is 8. The leg is what we're looking for. That's our x this time. And then bring down times radical 2. Now, to solve for x this time, what do we need to do? Shannon?
Oh, it's not saying divide by 8 or...
No, we're solving for x. Taylor?
Divide 8 by radical 2.
We need to divide both sides by radical 2 to get the x by itself. So we have x equals 8 over radical 2. Here's where your warm-up comes into play. We do not want to leave a radical in the denominator. So we need to rationalize that denominator. So thinking back to the warm-up, how did we get that radical out of the denominator? Jackson, you did one of these. What did we do?
Times it by itself.
Okay, multiply top and bottom by that denominator, in this case, radical 2. So from here, on top we have 8 radical 2. Radical 2 times radical 2, ladies and gentlemen, is 2. And last thing that we can do here,
Simplify.
we can simplify the 8 over 2. So this ends up to be 4 radical 2. Well, then we'll move on. Let's go ahead and look at number 3. So here we're looking for 2 different variables. We are given that the length of one leg is 14. Maddie Rolling, what would the length of the other leg be, which is x? 14. There's nothing that we need to do work-wise, really. You just have to understand that the 2 legs are congruent. To find the length of the hypotenuse, however, let's write out our relationship. The hypotenuse is equal to the leg times radical 2. Fill in what we know. Fill in what we know. We're looking for the hypotenuse. That's the variable y. The length of our leg is 14, and then bring down the times radical 2. And so the length of the hypotenuse is just 14 radical 2. Questions, comments? Okay. All right. Number 4, let's start in the back. Nate, what did your group have on number 4 for the value of x? I'm sorry?
8 radical 2.
Are you sure?
That's right.
For number 4?
Oh, 4. Oh, 18 radical.
There we go, 18 radical 2. All right, number 5. This one was a little tougher. Guadalupe, what did your group have for n?
8. Oh, n.
For n.
4 radical 2.
Okay, so n is 4 radical 2. What about m?
8.
Very good. That is 8. If you take the leg times radical 2 again, radical 2 times radical 2 is just 2. So that's 4 times 2. That is 8. Very good. All right, number 6. Justin, your group for the value of x.
I didn't get the value of x. Number 6. I don't know how to do it. I know how to do the rest of them. I still know how to do them.
Well, how would you start it?
Well, I got the hypotenuse is 18.
All right.
X would be one of the legs, and then radical 2.
Okay.
And then that's where I got stuck.
Well, what do you do to solve for x? Just algebra. It's just algebra.
Well, then I would do 18 radical 2, x would be 18 radical 2, right?
No. How do you get x by itself?
Well, I would divide.
You need to
Radical 2.
divide by radical 2. So x equals 18 over radical 2, but what do you need to do at that point?
And simplify it.
What?
You can simplify it.
How do you simplify that?
You go radical 2 on 18.
What?
You times 18 by radical 2.
Okay, we need to multiply top and bottom by radical 2. That's 18 radical 2 over 2, which is what?
9 radical 2.
That's 9 radical 2. All right, number 7, Maddie, your group. I guess we just have one variable, n.
Me?
Yeah,
X equals 6, or n equals 6.
n equals 6, good. And then last group, let's go Jenny, number 8. Good, the diagonal is 12, radical 2. You have a square. If you know the perimeter is 48, you know that each side is 12. The diagonal would essentially be the hypotenuse.